Hi everyone, it's Wednesday, which means it's time for another Chem Help ASAP live stream. So I thought this week we would talk about oxidation states, and that ties really nicely into balancing redox equations. So redox equations are equations that have an oxidation half reaction and a reduction half reaction. But the first thing we have to do is we have to be able to determine oxidation states. Now, one thing that people get confused about is thinking that oxidation states are charges always. And when we look at our rules, we'll see that yes, sometimes your oxidation state is your charge, but not always. So when we assign oxidation states, it's a way for us to keep track of electrons. And then again, ultimately, once we learn to assign oxidation states, then we're going to use that to balance equations where you have transfer of electrons. Okay, so just checking to make sure, OG Benchmarks, can you let me know if the audio is okay? It looks okay on my end, but just want to make sure that it's okay here. And let's go ahead and get started with our first couple of problems here. Okay, so first what I want to do is I want to go over the rules for assigning oxidation states. So we've got 6 rules, or really 6 guidelines for this. So we're just going to go through these 1 through 6, and then we'll do some practice, because I really feel like these rules start to make sense more when you actually start practicing with them. Okay, so our first rule is the oxidation state of an atom in its elemental form is 0. So for example, let me switch over here. So for example, if you have sodium in its elemental form, it's a solid at room temperature, it would have an oxidation state of 0. The tricky ones here are the diatomic gases. So for example, hydrogen in its elemental form is H2. The same is true for like the halogens as well. So chlorine in its elemental form is Cl2. These all have oxidation states of 0. So anytime you have an atom or an element in its elemental form, its oxidation state is 0. And this is usually when the element is just by itself. It's just the element like sodium, but there are a couple of diatomics out there, just a handful of them. Okay, so number 2 here is the oxidation state of a monoatomic ion is its charge. So I think this is where people get confused and they assume that charge is always the oxidation state. But it's the oxidation state for our monoatomic ions. So when we have, say, not sodium as a solid, but when we have sodium aqueous as an ion with a +1 charge, that charge is its oxidation state. But again, when we dive into like polyatomic ions, we're going to see something very different. Okay. Oh, good. I'm glad that sound is working good. Okay, great. That's always a question. How many times have we had trouble with sound? Okay. So that is rule number 2. Rule number 3. The oxidation state of hydrogen in a covalent compound is going to be +1. We're going to use this quite often. That's pretty straightforward. We're going to do the same thing for oxygen, but of course for oxygen, we're going to have an oxidation state of -2 or -2. The exception to this is peroxides, and then oxygen is going to be -1. We don't really see these very often. The most common example is hydrogen peroxide. So in hydrogen peroxide, the oxidation state of oxygen here is -1. The oxidation state of hydrogen here is actually +1. So that is the exception to the oxygen rule, but in general, oxygen is always going to be -2, and that's a great kind of rule to come back to. Okay, so rule number 5. In binary compounds, the more electronegative atom is assigned the negative oxidation state. So if you have 2 non-metals and you're trying to decide which one is going to have the negative oxidation state, which is